So yesterday we talked about sequences and series in general, right? Having, various different patterns. Today we're going to talk about a specific type of a sequence with a specific pattern, all right? Now, if you start with a number, let's say, I don't know, 2, right? So suppose you start with a number like 2. This is your, A1, okay? And now suppose the next number is this number plus 3. The next one is that one plus 3, then plus 3, then plus 3, right? So the pattern is just adding the same constant over and over and over again, right? There's something that happens here, which is if you take any 2 consecutive values, the difference is going to be the same number, right? 3. So 8 minus 5, 3. 11 minus 8, 3, right? This is called an arithmetic sequence. All right? So it's a sequence in which the difference between consecutive or successive terms is a constant, and that constant is called the common difference, and we give it the symbol D. So in that previous example, what would D equal? 3. Okay? So, and it doesn't say that D has to be positive or negative. So you could keep adding negative 2. Okay, so start at 1, keep adding negative 2, so negative 1, negative 3, negative 5, and so on. Okay? All right. So here, determine the common difference and find the next 4 terms of the arithmetic sequence. Okay, so D is, and you can take any 2 numbers, like successive numbers, to do this. I always just like to do the first 2. But you have to make sure to do like the second minus the first, right? Otherwise the sign will be different. So negative 36 minus negative 53, 17. That's D. Okay? Yeah. So D is 17. So that means to go from one number to the next, you're just adding 17. So now the next 4 numbers then, you're going to do like negative 19 plus 17. That's negative 2, and so on, right? So the next 4 numbers are going to be negative 2, 15, 32, 49. Okay? Okay. Now, let's see if we can, so if you know the common difference, I wonder, so this is 1, 2, 3, 4, 5, 6, 7. 49 was the 7th term, right? 49. I wonder if you know the common difference, D, I wonder if, there was a way that you can figure out like what the 52nd term is going to be, right? Do you think there is a way? Yeah? So look at what happened here. So let's see. Let's explore here for a minute, okay? Suppose A1 is 5 and D is 2. Okay? So let's write up some numbers here. A1, A2, A3. Oh, you know what? I'm going to space them out a little. Okay, so A1 is 5. A2 is 5 plus 2. And then is 5 plus, how many 2's am I going to add to the next one? 2, right? So 2 2's. The next one is 5 plus, how many 2's am I going to add? 3. The next one is 5 plus 4 2's, right? So look, there's already a pattern emerging, because it's always the first number, A1, plus something else. It's A1 plus a multiple of these D's. How many D's are we adding to each one? Whatever n is, how many of them do I add? N minus 1. So if I go further to an, the pattern is going to be the same number a1 plus n minus 1 times 2. Right? Okay? So if I were to write this in like symbols, this is a1 plus n minus 1 times d. And look, that's the first formula. You see that? And you guys came up with it on your own, right? So it's very much like from, like common sense from just looking and seeing a pattern. So that's called an explicit formula. All right? So we can find the nth term of an arithmetic sequence with the first term a1 and a common difference d explicitly using this. So I could be on term number 5 here, right? But I can like just jump to the 432nd term, okay, with that formula. You can also figure out a recursive formula that basically tells you what the next step is going to be only. The recursive formula doesn't let you jump down the line. It only tells you what the next step is. The way you write the recursive formula is this. There are 2 steps to it. First, you have to say a1 equals, and you have to put in the value. So a1 is 5. Then you say an is an minus 1 plus d. So the 2 things you have to enter into this are the value for a1 and the d. Okay? Right. So find the explicit and the recursive formula for these. Okay. So so a1 here is 14. That's just the first term. D is 3 minus 14, negative 11. So the explicit formula is, you say an is a1 plus n minus 1 times d, and just plug it in and simplify. So an is 14 plus n minus 1 times negative 11, right? But, we're upper level math students and we can simplify this, right? So this is 14 minus 11n plus 11. So an is negative 11n plus 25. Okay? Now, the recursive, here's what you do. You say a1 is equal to, what is it? 14, semicolon. An is an minus 1 minus 11. There isn't much work to do for that one once you've done everything else. Okay? So, this first one lets you jump down the line. You can go to like the 712th term. The next one helps you find the very next one if you're on a term. Like if you have the 50th, you can find the 51st. Okay? Okay, next one. Find the 41st term. So basically, you want A41. Okay, what have we given here? What have we been given? This is A1. So A1 is 11. D is 4 minus 11, which is how much? Negative 7, sorry. Okay, so A41 is equal to A1, which is 11, plus n minus 1 times negative 7. Okay, if I'm looking for A sub 41, what's n? N is 41. So this is going to be 11 plus 41 minus 1 times negative 7. So a sub 41 is negative 269. Yeah.
So find D from the second one minus the first one?
You basically any one minus the one prior. Yeah. So no, second minus first. Or you could do third minus second or fourth minus third.
Okay.
So any one minus the previous one. Okay? All right. Okay. We need the first term of the arithmetic sequence for which A44 is 229 and D is 8. So now I have the 44th term and I want A1. Well, we just plug it into the formula again, right? So we're going to say AN is A1 plus N minus 1 times D. AN is 229 is equal to A1, that's what I'm looking for, plus, what's N? No, N.
44.
44 minus 1 times 8. Okay, so here A1 is 115. Okay. I know. Yeah, they are fun. Okay, so let's talk about arithmetic means. Arithmetic means are terms between two non-consecutive terms in an arithmetic sequence. So for example, you've got a sequence, okay? Let's say you randomly pick the 7 and the 47, right? You pick one and then you go down the line and pick another one. All of the numbers that fell in between those are called the arithmetic means between 7 and 47. Okay? Okay. So, the next example is finding arithmetic means between two numbers. So suppose, right, you're looking for some weird ancient treasure and you find this thing and there's and you need this list of numbers because it's the code to something, except the code is missing, it's torn and it's missing the 7 numbers in between, and you're like, oh my God, way back when Miss Malikian taught us this thing, let's just do that, right? So you recall that from your memory and you're like, oh my God, okay. You better.
That's a good hypothetical situation.
You'd better. Yeah. Yeah. Okay. So we want to write an arithmetic sequence which has 5 arithmetic means between 6.2 and negative 1.6. So let's just see what that means. So you have a sequence 6.2 and then 5 numbers and then a negative 1.6. All right? So what do we know here? We know that A1 is 6.2. Okay? We know that AN, that's the last one, is negative 1.6. We know that N is 7, right? But what we don't know is what D is, because once we have D, then you can step, right? So, and I know there's multiple ways you can do this, but one way is AN is equal to A1 plus N minus 1 times D. So negative 1.6 is 6.2 plus N minus 1 is 6 times D. So when you subtract, this is negative 7.8 is equal to 6D, right? Divide by 6, D is negative 1.3. And okay, so it's the same number of steps. You could have easily also just done that mentally, right? Okay, so subtract, from 6.2 to negative 1.6, how much distance is it? And then divide it by 6. That's exactly what we did. Subtract, and then divide by however many steps there are. Okay?
So wouldn't it be divided by 5?
No, because then you also have to go to 1.6, because 1, 2, 3, 4, 5, 6. Yeah.
Is n the number of numbers that you want, or
N is the number on your list. So from 6.2 to 1.6. So now we're just going to keep adding or subtracting 1.3. So you get 4.9. What is this? 3.6, 2.3, 1.0, negative 0.3. Oh, and then it's negative 1.6. Isn't that cool? Okay. It's pretty cool. It's totally like a code, right? Yeah.
I can see myself using it in the future.
Yeah. Okay. Now. Okay, now here, right? So basically, if you take the difference between any two terms here, it's 1.3, right? And here, 1.3, or negative 1.3 rather, right? Now, so this is called, when you do that, first differences. So basically just like the difference between each successive term. Now let's talk about second differences. Okay. Subtracting successive terms in a sequence gives first differences. That's what we just talked about. When the differences are all the same, okay, the sequence, we say it's an arithmetic sequence, and you can express it like this. So basically, how is, okay, so AN is A1 plus N minus 1 times D, right? Correct? Okay. What if I brought, okay, so let's do this. Okay, another way of writing it is A1 plus, this is some constant. Give me a symbol for a constant. No, like a letter symbol, huh? X isn't a constant. Another one. Let's go M. Okay, times D. Okay? Now, can I rewrite that a different way? dm or md plus a1. Yeah? Does that look like mx plus b? A little bit, right? So, basically, if the first differences are the same, so suppose the first term in the sequence is a 5. Then the second term you add 2, that will be the next term. Then the third term you add another 2, that will be the first term, the next one. Then you add another 2, that will be the next one. So if you graphed all of those terms, you would get a line like this. All right? Now, however, when the first differences are not the same, then it's not an arithmetic sequence. In this case, you can look at second differences. And if those second differences are constant, then you get a quadratic expression, a quadratic relationship. Okay? So, look at what we're going to do here. We're going to find a quadratic model for this one. So look, let's take the first differences here. When you subtract these two, what's the difference? 8, 10, 12. Do you see how they're not the same? This is this is not an arithmetic sequence, right? Because you don't have a common difference, D. But what if you subtract this? You get a 2, 2, 2, 2. So you see how second differences are the same?
That is crazy.
Okay? So what you can do is you can write a model for this. And here's how we write the model. So basically, look, when I graph these, when n is 1, a is 12. When n is 2, 20, 3, 30, 4, 40. You get a quadratic equation, you get a parabola. So now we're going to find an equation for that parabola. So here's how we're going to do it. So when n equals 1, a1 equals 12. Okay? I can write that as a coordinate, 1, 12. When n is 2, a2 is 20. The coordinate for that is 2, 20. Uh-oh. Okay. When n, oh. No. It just crashed. It's so weird.
It's trying to revive itself.
Okay. So then okay. So when n is 3, a is 30, right? So that's 3, 30. Okay. Guess what we're going to do now?
Graph.
Nope, we're not going to graph. We're going to plug this into this equation. Okay? So, an is equal to an squared plus b times n plus c. Okay, this an is going to be the y coordinate, and these n's are going to be the x coordinate. So remember how we did it in the matrices chapter for that one where we had to come up with a parabola? And you had it on the test? That's what we're going to do here. So when you have 1, 12, right, you plug it in here and you get 12 is equal to a times 1 squared plus b times 1 plus c. When I had 2, 20, 20 is going to be 4a plus 2b plus c. Okay? Mm-hmm. Mm-hmm. 3 and 30, yup, 9a plus 6b plus c. That's a system of equations.
Are we going to like make the matrix like the addition?
Oh, 3b, sorry, thank you. So let's put this in matrix form. 1, 1, 1, 12. 4, 2, 1, 20. 9, 3, 1, 30. Now, use a calculator to put in reduced row echelon form. So let's do it. Okay.
Reduce your echelon form?
Yeah. The quickest way to do it is you go to menu, matrix, and vector. We want reduced row echelon form of menu, matrix, and vector. Create a matrix. We want it to be how much? A 3 by 4, correct? Okay, so let's put in the numbers. 1, 1, 1, 12. Remember to press tab in between, right? 4, 2, Tab 9 3 1 sorry 30. Okay, reduced row echelon form, there we go. 1 5 6, right? So that gives you 1 0 0 1 0 1 0 5 0 0 1 6. Okay, so that means A is 1, B is 5, and C is 6. So now the AN equals A times N squared plus BN plus C. That will be AN is equal to 1N squared plus 5N plus 6. Okay? And yes, that's the exact same equation as it told you here. Right? So now when you graph that parabola, you will get those exact same values. Let's graph that parabola, guys. Let's see it ourselves.
This is blowing my mind.
Yeah. So look, n squared plus 5n plus 6. Okay? By the way, let me show you something really fun. Graph this. Okay? Now, you can take your cursor to any white part of this grid and hold on to it, like grab it with the center button, and like you can like drag it to where you want. Yeah? Okay, so let's trace this. What are our terms in the sequence? 12, 20, blah, 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 right? Okay, so let's go. Menu, trace, graph trace. Okay, type in 1, enter. Oh, look, it's 12. That's the first thing on the list. 2, enter. Oh, it's 20. 3, enter. Oh my God. 4. Oh, 6. 72. Isn't that cool? That's pretty darn cool. So, I think this is a good place to stop for today.